So good night again, everybody. So basically, uh, for about a month now, I've been teaching my nephew and little cousin about AI and programming, and in the process of preparing stuff for them and teaching them certain things, I was surprised to see how much papers and tools and projects and stuff that are geared for that age group of even as young as 8 to 10. And I thought it was interesting, really interesting, the types of projects that they could do or learn to do at that age, which is why I thought it was worth sharing with you guys. So firstly, I'll talk a bit about the rationale behind why teach them these things at this age. Then I'll talk a bit about my approach to doing it. And then I'll go into more detail or a more detailed overview of how that approach is supposed to pan out and the different tools for each step of the way. So why teach them this? I mean, 8-year-olds already have so much on their plate as is, right? So the first, and I guess number one reason is for fun. So I think it's really important for them at that age to learn that it's not just that school is work and video games and YouTube is what's fun. You could have a kind of in between where you do something enjoyable with no pressure and still learn important things while doing that. So I guess that's the most immediate and most forefront reason. I guess each of these reasons get a bit longer term as they go, but the second reason has to do with the benefits of just learning programming in general. And that's the benefit to their problem solving and critical thinking skills that can be beneficial to other aspects of their, I guess, academic lives or just their lives in general. At this age too, there's a lot of different things they could learn that you wouldn't expect. So because going through these steps, every time we have I guess a class, they learn a lot of new words, they learn new terms, and they learn, I guess, labels to things they would have seen and interacted with in some way. So the next reason has to do with just providing a foundation for them to learn and do cooler stuff as they grow older if they choose to stick to this thing. And I think this is really important, especially during their formative years, because they start to learn a lot of things in things like AI in a non-intimidating way before they even realize it's intimidating topics. And the last reason, again, this is the most long-term, but it's the fact that they're already surrounded by AI in so many different ways and they're already using it in so many different ways. It would be good for them to have a better understanding of how that stuff works rather than just some black box, black magic understanding of what gets spit out to them through these quote unquote algorithms, because then they can become better consumers of the technology they use because they would understand it, they would better navigate it and have a better understanding of its flaws and opinions or biases instead of taking everything from it as fact. So I don't normally include quotes in presentations, but this particular quote seemed to kind of encapsulate, especially that last point really well. It was by, I believe this person was a grad student at MIT Media Labs, and they do a lot of really good work in this area. One of the primary tools I'll talk about later on came out of MIT Media Labs. And one of the main reasons I wanted to include this, aside from the quote, was just to give a quick mention to this open sourced curriculum right here. Because even though it's not the primary one I used and I didn't take too much from it, so which is why I don't want to go into too much detail about it, it's still a really good resource for people who may need a more structured or school-like approach to teaching AI to children. So I just wanted to put that link there for the sake of including it. So this is an overview of, I guess, the plan or the general phases. So the first is to go over concepts in whatever way that's best for them to understand and enjoy, especially. Then it'll be to go practice applying these concepts through different exercises in a more appropriate environment. So the concepts, it might be better to explain using like games and stuff, but then it would be better for them to get practice in a I guess, a more freeing environment, so to speak. Then once they've had practice applying those concepts, it'll be to show them how to put all of those things together. So making some project that ties in the different things they've learned and practice in individual exercises. And then lastly, once they've learned that, you can basically give them the freedom to make whatever they want to make, and I'll just be there to guide them along the way. So instead of to kind of break them away from the you do what I tell you to kind of regime of it, and give them a chance to, I guess, express their creativity through the things that they've learned. So firstly, the concepts. I thought this was an interesting paper that described, I guess, the big concepts that young people or children should learn about AI. The first is understanding how computers perceive the world versus how humans perceive the world. So that'll be explaining how images are processed and stuff like that, obviously in a kid-friendly way. The second would be basically explaining how computers or AI agents maintain some kind of representation for solving a problem and then use that representation for predicting or reasoning. The third is explaining that computers learn from large amounts of data and these agents establish these representations from looking at this type of data. The fourth gets a bit more complicated, but this is where you're basically explaining how agents, it's a difficult problem trying to get agents to interact with humans in an effective and comfortable way. So that has to do with like trying to solve problems without being intrusive or the limitations of natural language processing, for example. And the last is about, well, AI having both good and bad consequences of their application. So this would be getting into like ethics and bias and stuff like that. So obviously this is too much for like an 8-year-old or a 10-year-old. But I think at that stage, it's okay to just take 1 or 2, maybe 3, and aim for a shallow understanding of them, because these concepts were geared towards a K-12 program. So K-12 is from kindergarten to 12th grade, or Form 6 in our case. So in that sense, it makes sense to like, you could spread it out and deepen the understanding as they go along. But at this age, it's a good idea to know what the overall goal is and take a piece of that. So how do we teach them these concepts before they can practice it without completely boring them? And this was an important question to ask, because the very first session I had with them, there was a lot of yawning. And that's why I ended up turning into like games and a lot more interactive stuff, because even if you try to keep the explanations to a minimum, like it adds up. It adds up, and eventually they'll start to get kind of bored. So firstly, it's important to keep in mind just an overall air of familiarity and sticking to words they're comfortable with, analogies they're comfortable with, taking advantage of the things they do for fun. So the YouTube, their games especially, that kind of thing. Secondly, like I said before, interactive stuff and activities that can explain or exemplify the concepts that you're trying to explain and you're trying to bring across. In particular, experiments with Google has tons and tons and tons of those for different areas. And because each experiment, or basically like an app, is so focused on that one thing, it's a very direct application of whatever concept you're trying to bring across. It's also very wide in terms of breadth. So almost any age group, even adults, would enjoy or benefit from looking at these types of experiments. So it's easy to find a relevant one for the age group you're targeting. Lastly, there's Minecraft Education, which is essentially a version of Minecraft that has a lot of educational tools built into it, in the case like chemistry stuff, science stuff, not just programming, but in this case, the focus is on the programming part. So there's like a built-in block-based programming language and stuff in there to control, I guess, your character and certain entities within the game. So in general, even though when explaining the concepts, I would have made reference to the forms of AI they're commonly interact with. So things like Siri or Google Assistant, certain features of the camera app, or even like the Zoom backgrounds and stuff like that, where they, adding the virtual backgrounds, the things that they've been familiar with. I generally try to focus a bit more on computer vision type AI because it's very interactive and flashy and attention grabbing, and I wanted to stay consistent throughout the course of the entire plan. So even though at first I would have talked about those other forms, I generally stuck to this one because this would be what they learn about when in Minecraft education. This would be what they try to focus on when they're practicing different stuff. So because of that, I chose relevant AI experiments from experiments with Google that were around computer vision and targeted to that age group. So the first one was this called Quick Draw. And Quick Draw, the goal is basically you need to draw what the game tells you to, and you're trying to get the AI to guess what you're drawing. So, some of them are fairly obvious. This garden hose is a bit of a stretch. I don't know how I didn't get it trucked, but it was a fun game to them, especially, and it gave a very obvious example of how computer vision could be used. I mean, it's used in a game, but it's still used. The second example is called Magic Sketchpad. And here you'll pick an item or a thing or whatever. So in this case, it looks like a rat, but it was a cat. And when you'll draw the first piece, and as soon as you release your mouse, the AI will continue and complete the rest of the drawing. So here, it would have just been the circle, close to a circle that they drew, and then the RNN continued the rest and finished the cat that looks like a rat. Interestingly enough, too, the RNN behind this game was trained using data from the previous one, the doodles. So Minecraft education is actually not free, and it's pretty complicated. To me, it seems complicated to get access to it because you need to do it through Office 365 education accounts and provision to them and stuff. Yeah, it was confusing to me, but the hour of code segment of it is completely free. So you could download Minecraft Education and get access to this without paying or having to go through any of that Office stuff, which is very convenient for having that kind of thing set up like remotely if that's how you want to do things. But this particular session called Hour of Code is a hour-long, I guess you could call it like a mini game type of thing. They release every year. And there's usually some kind of theme. In this case, the 2019 theme was AI. So in here, you can have block-based programming like this. But if you have an older age group, there's also the option to choose Python over here. And the overall goal of this Hour of Code version was to teach this AI agent to prevent forest fires or help prevent forest fires. So it would walk them through the basics of programming and AI in the aims of doing that quest, I guess. So they would control this monkey-looking robot thing using their block-based programming and move the agent around like this and eventually teach it to detect flammable materials that could cause forest fires. So I thought it did a very good job of walking them through the basics of programming. So sequence, iteration, selection. In particular, I thought the way they did the sequence part was nice because they had this, it would first explain to them how to, well, it didn't really explain to them that well, but you could guide them along through it. So it's a good tool to explain to them these concepts because it's very interactive, it's very immediately resulting. So it keeps their attention and you can explain these concepts to them throughout the way without them getting bored. In particular, it brought across the idea of sequence and breaking down your algorithms into very small steps through something like this maze. Because the intuition would say, well, you walk forward, however many steps it takes to get to the bush, or you just say walk to the bush. But they can't do that. They need to walk 2 steps and then turn, and then walk 4 steps and then turn. So that these types of activities are very useful. So bringing those concepts across to them. One downside though is that in the game there's a lot going on, so they might get confused and not realize it's this simple. I mean, this example looks kind of long, but they did this. So what can help in that case is bringing it out of the game just for a little bit. So what I did, I made like a obstacle course in my room, and I pretended to be the robot, and they would give me commands. So that's that was like it's good to bring things out of the game and help them visualize it even clearer and slowly if that's what it takes, because the game doesn't allow that type of step-by-step debugging like you could do in person or through some other means. So as for the AI part, like I said, the goal was to prevent forest fires. So they needed to train the agent to detect flammable materials that pose a hazard. And in that, it would have been something like detecting dry brushes from healthy ones. So they would have basically labeled these images that would have come across here in front of the agent in order to teach it that these are the dry brushes, these are the healthy ones. And then later on, they would have used that aspect. They would have essentially used that model to go back to the block-based programming and use that in their code here to check if it's a brush and destroy the bad ones. So that would have essentially been the way to run them through the primary concepts, the basics of programming, the essence of AI and training an agent to do something. And there's multiple hour of code sessions. I think there's at least 2 that are free. So there's good material for them to get some practice before moving on to a more open or extendable proper language, essentially. And for that, I chose Scratch. There's basically 2 main ones. There's Scratch, and which is the thing I mentioned earlier that came out of MIT Media Labs. And there's code.org. Code.org has better introductory content, but because I did that entire section about concepts and using the experiments and Minecraft education, Scratch, the better introductory stuff wasn't as necessary, and Scratch is better in the long run because it's not just geared for kids, it's geared for 8 to 16 because of the amount that you could do with it and its extendability. So it's also code block based, just like the Minecraft stuff, but there's a lot of extensions and possible ways you can make cooler projects out of it because it works in sprites, so you could do animations and more interactive games. And there's also support for doing things with IoT. So you could hook up a Raspberry Pi or an Arduino and do more physical based stuff or robotic like stuff. And there's also extensions for machine learning, which is the one I'll talk about next. So there's also one from the Google experiments called Teachable Machine, but that's not as targeted for kids as this machine learning for kids. So this is the one I chose, but they're very similar services. So here, it basically simplifies the process of getting a model up and running, and then it gives them the chance to merge that in with their Scratch. So they could combine the programming with the ML model they come up with. And it's also quite easy to create your own data set because the accuracy doesn't need to be that great. And it's also very easy to use the model in Scratch in that same block-based way, which is why I chose this over the other one, because that felt more a bit focused for people who are new, but not people who are that new or kids. So they would then, after getting practice with creating models and interacting with Scratch and all that stuff, the next project that would tie all of those things together would be to make a rock, paper, scissors game. Because it's not a very complicated game, but it by incorporating the webcam, it gives a chance for them to use the ML model, an ML model they could create. So they could create that data set just by using their webcam. So you would like make the symbol or whatever on their webcam and just move it around. And the tool or the service there has a built-in function for splitting that video into tons of frames, and that would be their training set. I believe they use IBM's AI service. I think Watson is the name of it, and they back. So that's what that is powered by, and then it would connect to Scratch to make a very simple game. After which, like I said before, Scratch is very extendable. So it would basically be up to them which direction they want to go, whether it's incorporating IoT and whatever those kind of like bots that they sell that probably connect to Scratch as well. If they want to make more games or focus on animations and storytelling, or even music again through the IoT. So it would basically be up to them which direction they want to go and work together on. And yeah, that's about it. Short one, I guess, tonight. Any questions?
Yeah, very interesting stuff, Reshawn. I didn't realize they had all this stuff for kids. So what age group you were teaching for this?
Oh, they are 8 and 9.
Oh, just two people, students?
Yeah, okay. My nephew and my little cousin.
Okay. No, but I think this is it'd be useful if you had some kind of webinar on this stuff for students locally, primary age school students, because this stuff is is available online. So once you show them what to do, they would go and do it themselves, right?
Yeah, or could make it like a webinar for parents to help them through it or something, because it's not that difficult to say that they can't learn themselves, to teach them.
Yeah, because rather than playing games or something, this is more educational for them.
Yeah. It walks them away from the games because they still play in Minecraft, because that's kind of how I beat them into it.
Yeah, but at least they create as well, right? The fact is they create new content, so that the whole process of creating new stuff is important. Yeah. All right, thanks. Nothing else from me.
Any other questions?
Yeah, Reshawn, I have a quick question. I missed a few minutes in the beginning of the presentation, but I was wondering, what did your is the cousins you taught?
Well, nephew and cousin, but yeah.
What did they find was the most engaging and the one they learned the most like AI like concepts from?
Minecraft.
Okay, thought so.
Yeah, they're obsessed with Minecraft. So
really,
it was really easy to get them into this stuff because I don't know if they realize, but 90% of the time they were just reading or listening to me talk and explain things, but they were just always smiling and all ears just because it's Minecraft.
That's great then. Cool. Good job then.
Thanks.
I could just say though that I feel like Minecraft would a lot of younger kids and stuff would be more interested in Minecraft a lot more now, since because I play a bit more Minecraft, so like I know it's becoming a lot more popular. Yeah, and there's like updates and stuff coming up, so like Minecraft is getting a bit more popular and stuff, especially on things like Twitch and stuff. So I feel like a lot of younger people would be like open to like learning more about like stuff related to Minecraft, because it's just like so much more popular and stuff now. Yeah, well, becoming more popular again.
It can be kind of motivating to them to learn the programming, because then a possible option, if they're old enough, could be to learn Java and make their own Minecraft mods.
Yeah, for sure.
Reshawn, so to attest to how good Scratch is, me and a colleague, we did a workshop for Hillview last year, and we did it with Form 1 students teaching MIT Scratch. And I think nearly all the students really were interested right through. Parents were actually saying that they actually wanted them to come off the computer and stop using Scratch. So wow. I think Scratch is really good. as a nice base for programming on the whole.
Oh, thanks. Because I was kind of up in the air about Scratch versus code.org. I mean, the ML thing made it an easier choice, but in the earlier stages, I was a bit torn.
Okay. Okay, cool.
Yeah, Shiva, the stuff you use Scratch for, that was secondary
Yeah,
students?
that was Form 1 students. In
Form
Hillview.
1. Okay.